Have you ever wondered why the sky is blue? It's a question that has sparked curiosity and fueled countless conversations. It's a question that seems simple on the surface, but is in fact layered with fascinating scientific concepts. Now let's set the scene. Picture yourself on a sunny day looking up at the vast expanse of the sky. It's a canvas of blue, stretching out as far as the eye can see. But why is that so? Why isn't it a different color, say green or purple? The answer to this question lies in a phenomenon known as Rayleigh scattering. Rayleigh scattering, named after the British scientist Lord Rayleigh, is the scattering of light or other electromagnetic radiation by particles much smaller than the wavelength of the light. The light that we see from the sun is actually made up of many different colors. This light, in its journey through the Earth's atmosphere, collides with tiny gas molecules. When this happens, the light scatters in all directions. But here's the catch. Not all colors of light are scattered equally. You see, light travels as waves, and these waves have different lengths. Blue and violet light have the shortest wavelengths and are scattered more than other colors like red, orange, yellow, and green, which have longer wavelengths. So, when we look up at the sky, we're seeing this blue and violet light scattered across the atmosphere. But wait a minute, you might be thinking, if blue and violet light are scattered more, why isn't the sky purple? Well, there's a reason for that, and it has to do with our eyes and how they perceive color. But we'll get into that a bit later. So we've uncovered part of the mystery. We know that the sky is blue because of how light interacts with our atmosphere, but that's just the beginning. There's more to this story. Why blue? Why not green or red? The answer lies in the exploration of the color spectrum. So let's delve deeper into this fascinating phenomenon. Let's delve into the color spectrum. To understand why the sky is blue, we first need to understand light and colors. Let's imagine light as a traveler on an endless journey. It's a type of energy that zips through space at an incredible speed. But this energy doesn't travel in a straight line. Instead, it moves in waves, much like the swell of an ocean or the rise and fall of a roller coaster. Now, these waves aren't all the same size. Some are long, stretching out like a lazy cat on a Sunday afternoon, while others are short, tiny like a hummingbird's wings. Each wavelength corresponds to a different color in the spectrum of light. Yes, you heard that right. The colors we see are actually different lengths of light waves. Red light waves, for instance, are the longest. They're like the giant waves surfers dream of. On the other end of the spectrum, we have blue and violet light waves. They're the shortest, the smallest, the most energetic. They're like the rapid, choppy waves on a stormy sea. So, what does this have to do with our sky being blue? Well, as these waves of light travel through our atmosphere, they don't just keep to themselves. They interact with the tiny molecules of air, dust, and water in their path. And it's this interaction that causes the light to scatter or spread out in different directions. But here's the kicker. Shorter, smaller waves scatter more than longer ones. That means blue and violet light with their short, energetic waves scatter more than any other color. So if blue light scatters more, does it mean our sky is only blue? Not quite. But we're getting ahead of ourselves. That's a question for the next scene, where we'll dive deeper into the color-changing magic of our sky. Stay tuned. Ever noticed how the color of the sky changes throughout the day? It's a spectacle of nature, a ceaseless show that unfolds above us. The sky, our planet's vast canvas, doesn't stick to one hue but changes colors as the day progresses. But what causes these shifts in color? Let's start with the warm hues, the reds and oranges that paint the sky at dawn and dusk. These moments, known as sunrise and sunset, are when the sun is lower in the sky. At these times, the sunlight has to travel through more of Earth's atmosphere to reach our eyes. Now, remember our discussion about light scattering from the previous scene? Good, because it's about to come in handy. When the sun is low, the blue and green light gets scattered out of the line of sight. This scattering is due to the tiny oxygen and nitrogen molecules in Earth's atmosphere. With the blue and green light scattered to the four winds, what's left? The longer wavelength lights, such as red and orange, are less affected by this scattering. They continue on their path, unhindered, reaching our eyes and giving the sky its warm, inviting hues. But wait, it doesn't stop there. The amount of particles in the atmosphere can also influence the colors. we see. For instance, after a volcanic eruption, the increased particles in the atmosphere can lead to vibrant red and orange sunsets. On the other hand, a clear, unpolluted sky will often result in more brilliant blues and softer hues at sunrise and sunset. And what about the night sky? As the sun completely sets and light no longer scatters in the atmosphere, the sky turns black, revealing a twinkling array of stars. In essence, the changing colors of the sky are a result of the sun's changing position and the amount of light scattering that happens in the Earth's atmosphere. It's a fascinating dance of light and molecules that creates this daily spectacle. So, depending on the time of day and the amount of light scattering, we get to see the sky in different shades. But what about those gray, overcast days when the sky isn't blue at all, you might wonder? Well, on these days, it's the clouds that take center stage. Clouds are thick and dense, and they scatter all colors of light, not just blue. This scattering is much more uniform, meaning all colors get a fair chance to bounce around. Now, remember when we talked about how white light is a combination of all colors? That's exactly what's happening here. When all the colors are scattered almost equally, they combine to form white light. But since the clouds are not perfectly white and often have impurities, the light appears gray to us. So those gray overcast days are just another demonstration of the fascinating interplay of light and matter in our atmosphere. So the color of the sky can tell us a lot about what's happening up there in the atmosphere. So there you have it, the mystery of the blue sky solved. Let's take a quick trip down memory lane. We've learned that sunlight isn't just a simple, single color. No, it's a dazzling kaleidoscope of colors, a whole spectrum in fact. Each color has a different wavelength, with red light having the longest and blue and violet light having the shortest. This brings us to the key player in our story, blue light. Remember, blue light has short, small waves. This means it's more easily scattered in all directions when it collides with the tiny oxygen and nitrogen molecules in Earth's atmosphere. Now, you may be wondering, if violet light also has a short wavelength, why isn't the sky violet? Good question. While it's true that violet light is scattered more than blue light, our eyes are more sensitive to blue light and less sensitive to violet light. Plus, sunlight reaches us with less violet light to begin with, so the sky appears blue to us instead of violet. The color of the sky isn't a one-note song, though. It can change, depending on the amount of atmosphere sunlight has to pass through. Think of those breathtaking sunsets, when the sky is a canvas of reds, pinks, and oranges. That's because the sun is lower in the sky, and its light has to pass through more atmosphere. The longer path results in more blue and violet light being scattered out of the line of sight, and the longer wavelength colors like red, orange, and pink become dominant. So, to sum it up, the sky is blue because of the way Earth's atmosphere interacts with sunlight, scattering the shorter wavelength blue and violet light in all directions, and how our eyes perceive this light. It's a beautiful symphony of physics and biology, playing out right over our heads. Next time you look up at the sky, you'll know exactly why it's that beautiful shade of blue.